Hello world, it's Calcutron here with the 8th episode of our TI Basic tutorial series. In the last two episodes, we learned how to create loops with gotos as well as with while, and we saw that while loops were just an abstraction on loops made with gotos and labels. Today we're going to learn about two more types of loops that allow us to write the same loops we could before, but with a slightly nicer, more readable syntax. The first loop we're going to look at is the repeat loop, which is very similar to a while loop, but with two key differences. So let's get into our loop program and create something I think we might have done before, but we're going to write it one more time, and that's a loop that continually will display something to the screen. So maybe hello. And then ask if the user would like to continue looping. So we can ask if they want to loop. And we'll put in a space and we'll store that into L, which will be our loop variable, our loop condition. And so we'll go while L is true. And so if they put in anything non-zero, anything that's true, this will keep looping and displaying hello. And an important thing, we need to pre-initialize L to be 1, or anything non-zero, but 1 will do the trick, so that it enters this while loop at least once. So now let's run this and see what the behavior is. It shouldn't be anything too new. If it is, make sure you watch or re-watch the last couple of videos. So here we have our loop, and as soon as we hit 0, the loop will stop. So let's go ahead and convert our while loop to a repeat loop. And in other programming languages, this is sometimes called repeat until. What it's doing is, instead of looping while a condition is true, it's going to repeat the body of a loop until the condition becomes true. So one of the major differences, if we can just go in here and change this to a repeat, number 6 on the list, and it also takes just one condition after the repeat, and it ends with an end. So structurally it's very similar to while, actually almost identical, but it has two differences, like we said. And the first one is, as soon as L becomes true, it stops looping. And so that means it's similar to looping while it's not true. So while L is not true, it's going to keep displaying hello. Or this could be a more complicated expression, like L is greater than 5, or something along those lines. So if it's going to stop when L becomes true, then we should change out our message to be stop. So now, and we can pre-initialize this to 0 instead. So now, what it's going to do is, when we enter a 1, it will become true, and it will stop repeating because it's repeating until it becomes true. So let's go ahead and run this. And I'll show you it's the same behavior, but we put in a 0 to make it keep looping. And then when we want to stop, we can say 1, and it will stop. But you might notice it's a repeat until. And keyword there is repeat, meaning you can't repeat something unless you've done it once. So we can actually make it start out as true, and even though it won't continue if it's true, it will run the loop once while it is true. So we can do this, and it will enter the loop even though the condition started out true. So that is the other main difference from the while. So this will always run at least once. There's nothing you can make this condition that will make it not display hello. And sometimes that's useful and sometimes it's not. So when we had a while here before, if we started it as 0, it's very easy to change this back to a while. If we started L as 0, it would never enter this loop. It would terminate immediately. So two key differences, once again, is that it will always run the body of the repeat at least once, and it goes until the condition is true, so it loops while the condition is not true. So what we can do is we've shown that we can replace our repeat loops with while loops, or we can convert between them fairly easily. We can also replace our repeat loop, so let's turn this back to the repeat loop, and let's go ahead and not pre-initialize L. So that's one of the nice things. You can take out all the pre-initialization code for a repeat loop, or pre-initializing the condition. And what we can do is we can replace our repeat with go-tos and labels, and repeat is actually somewhat more straightforward to repeat with go-tos and labels, or to replace, sorry. So again, we're going to put a label up here, and we can call that label A or label A1. Let's just reiterate that it can be mixtures of a single letter and a single digit, or double letters or double digits. And then instead of ending, very straightforward, we do if the condition is not true. So if the condition is not true, then we want to go back to label A1, and then otherwise we don't go back, we skip this line if L is true, and then we just terminate our loop. So this is equivalent to that repeat that we had before, and let's exit this and just test it and make sure didn't make any mistakes. So yes, it entered the loop regardless of what L was equal to, and we tell it no, we don't want to stop. And then when we say yes, let's stop, it terminates. So repeat is actually somewhat simpler to translate into a system of go-tos and labels, whereas with a while we have to put in an extra label and go-to so that if our condition is false at the beginning, we jump all the way past this code. So let's get to the next type of loop, and we'll start by once again writing it as a while loop. And so let's do a count controlled loop where we get input from the user on how many times they want to loop. So we can say loop times or something. Ooh, all my spaces are becoming colons, or no, not colons, zeros. Alright, and then we want to store this into, let's say, E for end. So that's when we want to end our loop, is when we get to E. And then we'll start our counter at 1, and we'll use C for count. And now we want to loop while count is less than or equal to end. So we do want it to loop through the, we want it to execute the body when C is equal to E. When our count reaches the end, we want to execute once and then stop. And then we can do whatever we're going to do inside the loop. So right now, the only thing we're doing inside our loops is displaying hello, but in the future that could be something much, much more complicated. We could have an entire program inside of our loop that does something fantastic. And we can have loops inside of that and nest it all the way down. But for now, we're just displaying hello, simple. And then we want to update our count, so we'll add 1 to it and store it back into ourselves. So that will increment it by 1. And then this is our program. So we're going to get user input. We're going to loop while C is less than or equal to E. And we're going to update our count. So 3 things here. We find out when our loop is going to end. We find out when it's going to start, or where it's going to start, and we update, as well as we have our loop body. So let's run this, and let's say we want to loop 5 times, and we get 5 hellos. Let's say we want to loop once, we get 1 hello. Let's say we want to loop no times, we don't get any hellos. And that's because this while never enters, because 1 is not less than or equal to 0. So programmers write loops like this a lot, and we talked about how this is called a count-controlled loop, where we're counting a set number of times, or it might be a variable number of times depending on user input, but in general we know how many times we want to loop before we enter the loop. And so programmers did this so many times that they decided there needs to be a convenience. And something similar probably happened when the while loop was created. They were writing so many loops with go-tos and labels that they decided, we're doing this so often, we should use a convention or an abstraction in order to simplify this aspect of our code that we're rewriting. So sometimes people will say programmers are lazy, and what they mean by that is that programmers like to do as little work as possible by abstracting the low-level details, and the low-level details for a while loop are the labels and gotos, but the low-level details for a count-controlled loop are really what I was talking about before. You need a start value, which is 1, an end value, which is E. You need a count to be initialized. You need to go while the count is less than or equal to the end, and then you need to update. And so all of these things are abstracted away with our next loop, which is the for loop. And this one has slightly different syntax. So while and repeat, almost identical. You had the, well, let's put it back. You have the command, and then you have our condition here. But for takes a couple more arguments, and the first one, like we saw, is the loop variable we want to loop with. So we'll use C for count like before, and then the next thing is where do we want to start. And before we started with C at 1, so we'll put that back, C at 1, and then the next parameter is where we want C to end. We want C to end at E, and then something we didn't talk about with the while loops is we had down here this line C plus 1 stored in C. Well, what we could have also done is C plus 2 stored in E, or C plus 5 stored in E, or C minus 5 even. So we could have changed how much we increment or decrement C by, but we always did 1 because it seemed to be the most useful. And that's what the fourth argument or fourth parameter is to this for command, and that is how much we want to step each loop. So we want to start at 1, go to E, and we want to increment C by 1 every time through the loop. So we can take this out, and we'll see, well, first take note of how much more compact this is. We took things on 3 different lines and we squeezed them into 1, so there's the convenience factor that I was talking about that makes for loop interesting and useful, where even though you can do it with a while or you can do it with gotos, it's this compactness, this convenience. It's significantly shorter than our while loop was, and that's what makes this enticing and useful. So let's run this and verify that it has the same behavior. So let's say we want to loop 6 times, and we get 6 hellos. Let's say we want to loop twice, 2 hellos. Let's say we don't want to loop at all, no hellos. So I think that proves, or at least suggests, that this has the same behavior as our while loop. So now let's have some fun with it, and let's take out this input because it's a little bit annoying, and then let's take out, instead of displaying hello, let's display C so we can see exactly what it is through the loop. And we'll change this E to a, well, we can leave it as E, and then we'll set E over here from the home screen. So we want to loop from 1 to 4 stored in E, and now we'll see it displaying all the values of C through the loop. So the first time through, C is 1, and it goes through 2, 3, and 4. So through this loop, even though we are not changing C, every time we execute this body, C is taking on a different value between 1 and E with increments of 1. And I don't know, let's play around. Let's change this to a 3, and then we'll run it and see. And let's say, oh, so E was 4 again. So it started at 1. So it was important in our while loop that we were less than or equal to, and it's also important in the for loop that it's not going to do values greater than your end, but it will do your end value. So let's go in here, and let's say we want to go backwards. The way we do that is we put in a negative here, and then it's not going to work if we go from 1 to E backwards. 1 will never reach E in increments of -3. It's going to get further and further away from E every time. And let's change out our E to a constant value now. So 1 is never going to hit 5, no matter how many times you add -3. So let's see what this behavior is. And it actually stops right away. So what it's doing is it says, when this is negative, we actually want to go while 1 is greater than or equal to 5. And I could, but I'll leave it as an exercise for you to recreate a while loop that has the same behavior, going from 1 to 5 in increments of -3. Just won't, it's already gotten there. It's already gotten past 5 going downwards. So what we have to do is change the order, and we can start this at something larger. Let's start it at 15, and we'll go to, let's say, 3 in increments of -3, and we'll see this going down. So it goes through all the values that are multiples of 3, or that are multiples of 3 away from its start value, which is 15, all the way down to 3. And so there's one more convenience that they added, which is that a large amount of the time, I would say at least 90% of the time when I'm writing for loops, I want to increment by 1s. And so what they went ahead and did is made it so that if you leave out this 4th parameter, it defaults to incrementing by 1. So leaving this like this, let's go ahead and run it. It does exactly what we'd think. It goes from 3 to 13 in increments of 1, and it's exactly the same as explicitly saying we want to go in increments of 1. And if we loop by increments of 1, same behavior. One other thing we haven't looked at is we can actually do increments that are decimals. So we can go from 3 to, let's go to 3.5 by increments of 0.1, and we'll get 5 times through the loop. Actually, we're getting 6 times because we're starting at 3.0, so it's 0 through 5, which is 6 numbers, and it increments by 0.1, and you can also do negative decimals. So I guess that's about it for this episode. We learned about repeat until, or just the repeat loop, but it's often useful to think about it as repeat until. And we also learned about the for loop. So those are all the loop commands built into TI Basic that we're going to look at in this series, and I hope, or I think, that it's opened up the door to some new and interesting programs. So one of the programs we're going to be writing is a program that generates multiplication tables, and that's going to be in our separate series. It's going to be a standalone video where we're going to leverage the things we've learned so far. So that's for loops, while loops, well, probably not while loops, but for loops and if statements and variables and logic, and it's going to leverage all of that in order to create a program that will generate a handy multiplication table. And once again, that's going to be a standalone video that won't be a part of this series, but if you think you need extra practice with for loops and everything we've learned thus far, that'd be a good one to check out next. So if you still have any questions or comments or concerns, please leave them in the comment section below. Otherwise, I hope you enjoyed this video. Bye-bye.